All right, in this section, 8.2 deals with arithmetic sequences and series. In an arithmetic sequence or series, there is a thing called a constant difference, which means you're either adding or subtracting some value to get from one term to the next in the sequence. An example of that would be, let's say we have 2, then 4, then 6, then 8, and so on and so forth. So that means from here to there, you're adding 2 each time. Now, if you were to plot these points or these coordinates on a coordinate plane, this is the first term, that's the second term, that's the third term, that's the fourth term. So you would have the coordinate 1, 2, 2, 4, 3, 6, 4, 8. So 1, 2, 2, 4, 3, 6, and 4, 8. And if you look at those points, hey, they are in a straight line. Going like that. So, an arithmetic sequence can be modeled by a linear equation, which is in the form of y equals mx plus b, or y minus y1 equals m times x minus x1. Either way. Now, in this sequence, how much does it go up and over? Well, that value is 2. So, which is the slope, that is also the constant difference. So the slope is the same thing as the constant difference in an arithmetic sequence. And so in this particular instance, you would have y equals 2x plus, and then it crosses at 0, so it's 2x plus 0. Now, typically they don't use y and x when you're dealing with a sequence, so they would say 2n plus 0. So a sub n equals 2n plus 0 would be how it is written. So if we are looking at this sequence here, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it is being 1 is being added each time. And same thing here, because you're dealing with, this is the first term, so you would have n equals n, because the slope is 1, because it's going up one time, and if you have to find where it crosses the y-axis, that is still 0. Now then, if we look at this one down here, this one is adding 4. Each time, so therefore the slope or the constant difference is 4. So then each a sub n is going to equal 4n, and then you have to figure out what would be the value where it crosses the y-axis. Well, you know that the coordinate 1, 3 is there because of this point. And so, and if our constant difference is 4, that means our next value is 4 from that, which would be down here at a negative 1. So it is 4n minus 1. So basically this right here kind of like is considered the zero term. And you get that term by just subtracting whatever your constant difference is from the first term. All right, so that's how you find the equation for an arithmetic sequence. Now, if we turn this into a series, would be the sum of all terms, depending on how many terms you're dealing with. So something like that, or n equals 1 to whatever for a sub n. Well, let's look back at these here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now that has an ending that doesn't continue on forever and ever. So if we wanted to find the sum of these terms by just taking these and adding them together, that's 10 terms. So if we were writing this in summation notation, n would equal 1 to 10 for a sub n. And we know a sub n is, or a sub 1 is 1, and all the way to 10. And so now if you take out your calculator and put all of that in and just add it up, you will get 55. All right. Now if you look at this, that's all fine and dandy if you only have 10 terms. But if this were a sequence that had a dot, dot, dot after it and went on forever, and you said, okay, the 100 terms, well, now that's going to take you a little while longer to enter all that into your calculator. So probably a better way to do that. Well, if we look at this, if you take this term and this term way over here, if we're just dealing with the 10 again, what is 1 plus 10? Oh, that's 11. And if you take the second term and add it to the second to last term, you would have 2 plus 9. Hey, that's also 11. And if you take the third term and the third to the last term, that would be 3 plus 8, which is 11. And then if you have 4 and you add it to 7, it equals 11 again. And if you have 5 plus 6, you get 11 as well. And how many 11s are there? Well, there are 5 of them, and 11 times 5 is 55. Well, let's see then. How does this apply? Well, 5 is, how many terms do we have in this sequence from here to there? Hey, there's 10 terms. And this number is 5. It's half of that, isn't it? And 11, 11, 11, and 11 is found by adding up all of the different, the first and the last, the second and the second to the last, and then all that. So the easiest terms to find would be this group right here, the first term and the last term. And so if you take the first term of your sequence and you add the last term of your sequence, and then you take that and multiply it by the number of terms you're dealing with divided by 2, you will get this sum as well. Because the first or 10 is the number of terms divided by 2, and the first term is 1 plus the last term is 10. Okay, so if we turn this into, like I said, 100, well, it's the same thing. You would have 100 over 2 equals, the first term is still 1. Now the last term, you'd have to figure that out. Well, in this sequence, the term number is that they actually, so 1 plus 100. And 100 divided by 2 is 50, and that would be 101. Oh, why am I putting an equal sign in there? We don't need that. That should be a times sign, multiplication. And then 50 times 101 is 5050. All right. So you're probably thinking, okay, well, what happens if you have an odd number of values in your sequence? Like this one, if we were only dealing with these terms. Let's get rid of the 4. No, we're going to leave the 4n minus 1 there. Well, if you look at this, if you still take the first and the last term, 3 plus 19 is equal to 22. 7 plus 15 is equal to 22. And then you will have this lone term left over. And hey, 11. How is 11 related to 22? Well, it's half of it. So you have two 22s and a half of a 22. So then let's see, if you use that formula that we have, 5, because there's 5 terms, 5 over 2, and then you take the first term and the last term. Well, 5 divided by 2 is 2.5. And don't we have 2.5 22s here? Yeah, we do. So 2.5 times 22. Oh. And that is also 55. Now then, if we wanted to find the sum of the first, let's say, 60 terms. Do the same thing. So then we would have 60 over 2. The first term is 3 plus, and now we have to find the 60th term. Well, how do you find the 60th term? Well, that's where this comes into play. So if you substitute a 60 for that, 60 times 4 is 240 minus 1 is 239. So the 60th term is 239. And 239 plus 3 is 242 times 30. And that will get you 7,260 is your answer. So the sum of the first 60 terms would be 7,260. And if you were going to write that in summation notation, it would be like n equals 1 to 60 for 4n minus 1. So if you can figure out the first term and the last term and the total number of terms you have, you can find the sum. It doesn't matter how many there are. Or if you want to, when it's something short like this, you can just add them all up. So that is what an arithmetic sequence and an arithmetic series looks like, and what section 8.2 is all about.